Just going to talk today about ECMAScript 6. How many of you guys code JavaScript day to day? All right, good. How many of you guys have actually played around with ECMAScript 6 at all? Read up on it a little bit? Okay. We're just going to kind of run through really what's in ECMAScript 6, what the new features are, and we're going to see how you can use that today, and we're going to just run through a couple of examples as kind of what's going on with the spec crew, and any questions you have, we'll run through those. Should you use it today? Definitely, maybe. So we're at a point where there are transpilers, and a lot of what we really want to do with ES6 can actually be done in IE9 and later, which has ES5. And so we're going to focus primarily on those features that can kind of be replicated. We're going to go through like which ones are kind of on the edge of being, syntactic sugar versus actual new features. Just to go kind of to look at what we have with IE8, it's down to 3.8%. So unless you have that as a hard requirement on a project, it's on the verge of being something you don't have to worry about. And it's great to be able to say IE8 instead of IE6 anyway. So the ES5 compatibility chart, if you look at it, IE8 has a whole one item that it can actually do. So yeah, there's actually an ES6 compatibility chart out there, but it's not as reliable right now. I mean, it's the way Traceur does a lot of their polyfilling. I don't think it's actually done until it's used. So it looks like some of the features aren't there when it does the checks for it. So Evergreen Browsers, this is what's going to be coming in the next couple of years. So you have a considerably more rapid release cycle, and they're also going to start with the ECMAScript spec. Starting with 7, they're going to do kind of the train model that you see browsers doing, where they release new features that are time-boxed. So the train goes out whether or not the features are there. So the tools that are really there to do most of the transpiling and the shimming and all that, they're listed here. Traceur is the one we're really going to focus on. It's done by Google. It's by far the most complete. Regenerator/recast, we're going to walk through a sample of how you can transform your ES6 code to ES5. You can also go the other way, and there's a great talk out there by Ben Newman at Facebook where he talks about what he did, and he's apparently got a 32-core desktop computer, and he just talks about how much code he did in 2 seconds. So it's kind of cool. And if everything's out there on the website, F5 Complex, and then there's the slides are on GitHub. And if you want to play around with the Traceur REPL, you can hit it at that URL. So, and also, yeah, it's down at the bottom left. So we're going to go along. And if you're in the Traceur REPL, this is the first ES6 you can write for some of you. What you're here, we have string templating, so it's any variable that is in scope. You can use $, and then the brackets to have access to it inside of your strings. They're also multi-line, so that's nice. And we're going to run through a couple quick ones here. So there's arrow functions, the new features, arrow functions, classes, generators, iterators. You have comprehension, spread, destructure, various map features that you've kind of definitely missed with JavaScript, proxies, reflection, object functions, import, export, math functions, and string functions. And import, export's really modules. So there's really 2 types of features. I kind of hinted at this earlier. There's syntactic sugar and features that are completely new and can't be replicated. So this is a REST parameter. So a REST parameter is if you put it as the last argument to a function, anything that is following at that index or later in the parameters is actually converted into an array. And so you can see with the example there, if you pass in 1, 2, 3, 4 as an argument, then 1 is the set to initial parameter, and 2, 3, 4 is set to the REST parameters. And you can do a lot of this in ES5, and here's kind of an example of how to do that. So unrest is just if you do unrest initially with the same arguments 1, 2, 3, 4, it would just print out 1, 2. And if you wrap that with rest in, you can actually make it do the exact same behavior of the other one. And there's actually a bug in this. Can anyone have an idea on that? Because you can do any number of parameters on the You do any number of parameters before the rest parameters, so that one in the slice call. I didn't see anyone raising their hand, sorry. You didn't. If you guys weren't looking around. So that should actually be the number of arguments in the function. And really, new functionality is proxy. There's 13 or so different traps, and you can wrap that around any existing object. And you can even null out the original existing object and intercept any of the calls to it. So there's like getters, setters, there's property names, descriptors, all that stuff. And Firefox is the only one that has a near complete implementation, but if you check their website, they say that theirs is not yet complete. And that's something you really run into when you're looking at a lot of the ECMAScript 6 stuff. There is the documentation often lags what's actually done in the code. I mean, imagine that. Like, for example, Traceur doesn't mention any of the polyfills on their site or anything like that, so they're actually, it's more complete than it looks. And we're going to look at the generated code really quickly that generators create. So generator is actually, it's a JavaScript function that can be yielded. So it, until you call next on the response of a generator, it's not going to do the math, do the calculations to get the next one. So that cleans up how you can handle some of the code. I used it to do, was anyone here for the last talk, Andrews? Okay. They had a, there was a, he mentioned doing a Fibonacci and how to compute it and store it, and I did one of those in ECMAScript 6, and he tried to get 475,000th Fibonacci sequence, and JavaScript did it faster than everyone else, and the answer is infinity. But so here you pass base in, anything less than 4, it's really doing the same thing, plus base, it's just going to count. And this is what the generated code actually looks like. So anything that you do as a generator really gets broken out into case statements, and it's really not fun to look at, but if you spend a lot of time, you could actually figure it out. It's not really something you have to worry about. And what you see here is there is a Traceur runtime, so anytime you do any Traceur code, you have to include that runtime. And what it does is it's a lot of the commonly used functions that the Traceur code generates. It's kind of like a library. And so already we've already looked at REST parameters, proxies, generators, and array comprehension. And now we're going to kind of look at how transpilers work and do the arrow function. So everything that the JavaScript interpreter, it converts your JavaScript into syntax trees and can operate on them. And you can look at the S-Prima parser, and it's kind of cool to see exactly what the code is converted to when it's run by the interpreter, by JavaScript. So trivial example, the semicolon it yields a type empty statement. And then it goes, I just want to really show how much it changes from one thing to the next. So, I mean, just making a new function that takes an argument and prints out. I should have made the console log 1 actually use the argument. But anyway, so what you yield here is this very long mess. And I mean, it's a lot of brackets and parentheses. I guess not parentheses, but yeah, brackets, square brackets. And what we're going to do is we're going to display it more compactly, and we're going to look at it as, in this format. So you're missing some of the information there, but you kind of get the idea. And we're going to see this again as we go to the arrow function. So the arrow function is just, you don't have to use function anymore whenever you're declaring a simple function. You don't even have to include the return, because if there is no block there, it'll return that immediate evaluation of that. So you have two versions of sum that are pretty equal. And there's one other thing, though. If you use the arrow function, it's actually bound to the current this for its lifetime. And I'm assuming that's for performance. There are performance implications, because you know exactly where to call when you're evaluating. So in ES5, it's roughly equivalent to the first one, but it actually has the bind this at the end. And the abstract syntax tree of both of those. So you have the arrow function expression and the binary expression, which is a plus b. And then the equivalent in ES5, which is what we're going to convert to. And you'll notice that it's really kind of similar. The call expression is calling bind But other than that, the function expression is very similar to the arrow function expression. And one of the tools out there I mentioned earlier is React. It allows you to kind of rewrite your source code, keeps comments and everything, formatting in place. It only changes what you actually need to. So that's kind of cool. And there's a builder that does some of the syntax, and it actually it doesn't have very good documentation, and it's not like your editor is going to autocomplete any of it for you, but it gives really good output for if you're missing a field. And all of that's based on the Mozilla Parser API. That's what Esprima uses a lot of too. And so the important part here is you see the member expression under the call expression. We're just changing the arrow function expression that's passed in into a function expression. And fixed body just adds a body around that, which is just for completeness. There's kind of what we're looking at. And it's probably not very intuitive as you're looking at it now, but it's something that if you're dealing with a spec and it does end up changing, then you can actually rewrite your code a little bit more intelligently than just doing search and replace. And I tried this on something that we were converting to a promise, and that's not a good idea. Because I mean, you're taking in order, going to out of order, and yeah. And just to run through some other features really quickly. So here are default parameters. You can put an equal after any of your arguments and specify the default for them. So here, if you call test with nothing, you get 1, 0 as an array, and then 1. We also have destructuring. So what this is doing is we're actually reading username and password out of the object on the right. And so you can see the data that's out. But you can actually do destructuring with it nested. And you have to do, you'd put a colon after the first part that you're searching for, and then you do your variable name. And we can look at that later if people want to. And destructuring arrays. So here's first, second, third. The first 3 items in the array are going to get set to 0, 1, and 2, respectively. You can also do 2 commas back to back to skip 1, if that's what you needed. So here's the generator again. And so when we looked at the generator the first time, it actually did an array comprehension. So it converted the generator to an array, which it's no longer lazy at that point. And here it kind of is lazy. So whenever you call next, it does compute the next value. So if you're generating test me, it outputs each one. And the output of a generator is actually the value with a done status, whether or not it's done. Let and const are new features that really aren't there yet. So in Traceur, you can actually redefine your consts, which is, fun. And the better way to handle that probably, and it's something that they're kind of changing how they organize their code to be more feature-driven instead of right now they have it used to be under a lot fewer flags than it is now. And so with let and const, I mean, the ideal case there would just be that your linter actually warns you if you're doing something like that. But if you import something from another file, I can see the linter breaking down, obviously. Probably should finish that. So here's an example of comprehensions. And it's just really taking the generator that you have or an array, anything that's iterable. So JavaScript now has a concept of iterables. There's a symbol, which is a new feature, which is a symbol is guaranteed to be unique. So if you want to make a name on an object that doesn't conflict with anything else and make sure that they don't merge, then you can make a symbol, and that symbol can be used. And so iterable is a unique one that's guaranteed to be unique, so you get access to that and you add it to your class. And here, so with the generator comprehension, on the second one, I add a conditional as well. If x is divisible by 2, then we show it. Or actually, and I think I show the opposite. The spread operator, if you, anything that you call with 3 dots in front of it is actually going to get spread out into it's going to be called as individual parameters. So it's like you're doing call, a function.call, you do this, and then you expand out anything that was in the array. So the equivalent, Yeah, this is just like calling, it's also like calling with an apply. So it's like applying an array is really what it's doing, same thing. And yeah, and the call, the equivalent to that is calling each one individually. And template strings, which you've already really seen, this is just if you're trying to build a URL, maybe for a endpoint, you could do something like that. And one of the examples that I was trying to think of really good examples for this, and I know I've gone through some of this too fast, and if you've had any questions, I mean, obviously feel free to add them in, but kind of a practical use case for some of this is, I think you could use generators for tab management if you need to do something like that. So with ARIA accessibility, if you have a really complex page, you want to change tab order and make it where it actually reads well to a computer, right, so that accessible technology can really access that data. And one of the examples that Firefox uses is for proxies. You can actually manage setting a ARIA active flag or ARIA checked by having a proxy that covers multiple items in a list, things like that. So here is kind of the setup functions. So what we're using is we're doing a check on any element. If it has a tab index greater than or equal to 0, then we know that it is something that we want to include in the tab order. So if the tab is -1, then it wouldn't be included, but it'd still be focusable. All that stuff that I guess you probably don't come across in your normal JavaScript lives. But and then also a time function, which is just wrapping something, and that's just really it was for testing some of the code that I wrote in the next page. So, and there's also a function isHidden that it does the same thing that jQuery does to actually determine if an element's visible on the page. It checks the offset width and height. And then we're adding a new one, which is just the ARIA hidden true. And because so again, like with ARIA stuff, you have like the roving tab model where you just keep changing the tab index. And then you can do everything with tab index -1. And it's just kind of, neither one of those are really great ways to manage that. So we're kind of looking at a different way. So here is an implementation. This is a class, which is now a new feature. You can do class, whatever, extends, and then the name of another class. And you still have access to all the prototypical inheritance that you're used to, but it's a little cleaner, a little more intuitive. I come from a Java pedigree, so I'm definitely more used to it. But it's nothing that's really horribly new. It's just a different way of thinking about it. You can also do generators inside of here. And what we're really doing is we're doing I think it's a pre-order traversal of the tree starting in a certain DOM element. And that's just done with the generator. So I mean, it's really easy. Look at any of the yield statements. You're either going yourself to the person next to you or to your immediate child, to the node next to you or to the immediate child. And I mean, I think that's a really clean way to do it. And we also have a focus array function that converts it into array. Because really with tab indexes, even though this doesn't show it, you'd have to do the 2, 3, 4 variant and actually include some of that. And so what I really saw when I was doing this is I was trying to get a feel for it, make sure that we had decent speed going along with this. And on CNN, I think it was about 70 milliseconds to get all the focusable elements on the page. And it's actually considerably slower than just doing a selector, but you're also doing the parent check, you're walking the parent tree, and you're dealing with some of the generated code. And when I added some of that on CNN.com, it was about 15 milliseconds versus 70 milliseconds. And so anything you want to do to just, if you wanted to go from Traceur REPL and go directly into another site and use this code just to kind of try it out, all you have to do is add the script tag for the Traceur runtime, and you can copy the code that's generated straight in. And we'll look at the Traceur REPL, assuming it can be easily shown on the screen. And so another feature that's added in ES6 are weak maps. So you have map, set, weak map, and set. And what they really do is they don't necessarily keep the item in memory. If you add an object like a DOM element to the weak map, it's not going to keep it in memory. It's going to actually get garbage collected. But you have no control over it. With a weak map, you don't even necessarily know you don't know what values are in there. So if you've lost reference to it, you have to wait for it either to be passed back to you, or and you're really stuck. But there's a set, a has, a delete. Those are really the only options on the weak map. And so here's just a utility function. It's another generator. It's just adding a sliding window of fields. So we're going to use that on the next page. If you're doing tab order, you just map that. You put each of those in the map, and you have your tab index. So if you're on any element, you pass that element in, and you get the next one that you go to. Is there anything else in there? So here is the parse focusable. We added a forward and reverse weak map, and we in build tab order, we use the sliding window to just set those values. And I mean, it's pretty, I feel like you get a lot for a pretty few lines of code with that. But it's, there's currently a discussion on the mailing list where it's really not something that you want to use for management of your views, like if you're doing backbone views or anything like that, just because you don't really have control over the memory. So if you're trying to do that, you're really kind of cheating the system. And I'm probably on the verge of that by doing the lookup with that. But if it's really, the only check we'd have to add is we'd have to check if the parent element wasn't set to know if it had gotten removed or something like that. And obviously you have to worry about updating it. But that's a whole different matter. You'd have to use a mutation observer, subtree modification, all that. Here, watch for that. So here's an example of promises, just wrapping a XML HTTP request. So in the constructor, you take in a URL, the method, getter, post, and the data. And so when you're creating a promise, you pass in a function with resolve and reject. So that resolve function there is going to handle whether or not the promise is actually resolved or rejected. And throwing the error there actually rejects that promise. So that's what happens on the timeout. So anything that I'll show you how to access it on the next slide here. There's also, if you wanted to extend the class, like to add a data type resolver for JSON, I mean, this is all you'd have to do. So that's kind of nice. It's probably a little cleaner than what we can do now. But I mean, that's one of the best things about JavaScript is you can be creative in how you tackle problems. So I mean, there's all sorts of different things you can do. So I know this comes across as very class-based because it's a new feature, but you don't have to use that with the new features. So here we're just making a CORS request to some OpenStreetMap data, and if you want to try that in the Traceur compiler, it just works. Just copy the last slide in this one, and it's pretty fairly straightforward. And you're actually, what you'd probably really want to do is make the data that's returned more robust, have more data. So kind of like the jQuery object has all the different methods that are on the XML HTTP request. And then you could destructure that and get the actual variables that you wanted. So modules are a new feature that are being added. And this is kind of one of the areas where the TC39, Technical Committee 39, it's all the different people that make up the spec. There's been some contention. It's like, are they designing for static verification or more for what users really want? And they're in the process of kind of tweaking some of that because they felt it was kind of confusing, and we'll see a little bit of that on the next page. But there's a new site out there, jsmodules.io, and I'm going to I need to update this and include some more links on that. So here's the syntax. We'll assume there's a class called lexer.js, and you just export the actual item that was created in there. And then the next 4 lines are different ways to do the module imports. For any export, you can do a default, so that if you use that without doing a default, means that you don't have to do the destructuring when you're doing the import. For most cases. So when you're doing, like if you see the import lexer from lexer, the second item there, then you're actually destructuring lexer from the lexer object that is all of the imports. So from the lexer class. So you can have multiple exports here. You could have export lexer, export foo, export bar, and then you could actually import lexer foo bar all as one line there. And that way, because I know with require, you end up putting everything into one object, and you have the other data available there. So to enable that kind of behavior like you'd expect from require, they added the module syntax, which they're talking about taking out in favor of the next line. And so module lexer from lexer takes anything that is exported in that class and puts it all into one object that you can reference, that you can use. There's also the other format, which they're getting rid of. If they get rid of module, then they're going to go to import star as lexer from lexer, and that's going to be discussed at the next meeting, which is July 28th, 29th. And the last sample here, since you didn't do a default export, then you can't actually just import by name without doing the destructuring or the star syntax. So in another example of that where you do have more exports, you can do so here's just, it's a new line, space, word, and punct, and just there's various ways of exporting that. So when you're doing the export default, you're actually putting that all in one object, and that's what's going to be available when you do the default import. You can also get each one of those individually, and you can also do the module import. So it's, I mean, overall, you guys think that's a few too many options? Is that intuitive to many people out there? Okay. Not really? Okay. I mean, they're tweaking that, and they're trying to come up with a better system. Just because it's not as intuitive as maybe what you're used to. But I mean, if you really think about it, if you're using module systems, that probably wasn't intuitive to you at first when you started doing this stuff. And so really the tools that are out there, so the one that I'm familiar with, Grunt Traceur and Gulp Traceur, I actually have a fork of the Grunt Traceur, and it was broken. I fixed it. I should have probably committed it back to the master, but we kind of diverged a little bit there. But it's really pretty easy to use. I mean, you specify the structure that you want to start from, your source, you add a watch tied to any of those commands, and it'll convert it and put it into your bin directory, which is, it's not necessarily in the same file, but it can be, and it can already be minified. And all the Angular tools, they seem to use Gulp Traceur, and Angular is really doing a lot of their development for version 2. All of it's really done in ECMAScript 6, and they're using Traceur compiler for now. And in the future, when it's available natively in the browsers, we'll switch to that. And so, I mean, here's really the steps to use Grunt Traceur. So install it, update your grunt file, add a watcher, and you're pretty much there. And so February 11th, they were talking about, can this be used in production? There was a thread on the news group. And the real gist, what Google, their statement was, yes, it's out there, probably stay away from modules. And that's pretty much what I found. I've been able to work with modules. They're actually integrating the ES6 module loader, which is another project out there on GitHub, into Traceur directly, and they're in the process of finishing that up. They might actually have done that last big push. So what they're currently really discussing in the spec is generator comprehensions. They're talking about taking that out so they can add more functional features like map, flat map, and all that stuff directly to it, and that would be onto ES7. ES6 modules, we talked about that a little bit, and you really don't want to have to use two module systems in your code. So, I mean, there's CommonJS and Require, and that's or AMD, and that's something they're worried about. And then no one really got this message, but object.observe is actually in ES7, but it's they're still kind of pushing forward with it, and that's something that I've seen a fair amount of. It's like people have these features that they want, and they say, oh, this is the greatest thing since sliced bread, but it's not really in the spec yet. So that's kind of interesting, but you can kind of see where people are interested in it. Like I know Angular would use this very heavily for dirty watching for their projects. And that said, they did do a non-native version, and they were actually able to get really solid speeds out of that. But another thing that I kind of meant to mention as I was going through a lot of this that I didn't is I think that we're kind of looking at, for the longest time, you're told not to extend the prototypes of objects. But I think as long as it's well spec'd, we're kind of seeing that that doesn't have to always be the case. You've got a sweet JS that does macros in JavaScript, and you can implement some of the class semantics and other things like that. And if you do have to deviate from the spec, I mean, hopefully you have kind of the tools to get an idea of how to either get back with the spec or to kind of roll your own features for a couple things. And I think there's a lot of possibility there. Let's see what else. That's really most of what I had. I'll gladly show some of the Traceur stuff live here. But let's open it up for questions, and we can kind of go with that. And if anyone wants to, we can look at any of that. So is there anybody have anything they really want to ask? Really, nothing? All right. Do you guys want to see some of the stuff actually in action? Any of that? No? All right. Can you read that remotely? So this is when I tried doing the Fibonacci sequence. So you can see down in the console that it is actually infinity. But so all you have to do, anything that you type in here is really, it gets converted on the right-hand side, and you actually have source highlighting. Let me fix something up towards the top so it's not off the screen. So you can see current over there is actually highlighted. So any code that you write, you can actually trace back to exactly what line caused the problem. And so that's kind of nice. And just get in here and play around. I mean, you'll find that it really is kind of intuitive. There's the Koa library, there's Vision. They do a bunch of libraries that use ES6 generators, they're hidden behind the Harmony flag in Node. And that's going to be probably the most accessible thing without having to worry about transpilers or anything like that right now. And so here, let's grab another one. You see there's actually no array from native. In the Firefox browser, but you are actually able to use it inside the Traceur code. So I mean, it's doing a polyfill there, but then there's also there we go. Here's the ES6 table. And so you saw that we were able to do it. There was an array.from in the, see now, this is not helping my you should use it today, is it? But, so what you have is, you have to pick certain features that are really available to use. But, so Traceur and array.from, let's search for that. And what we're going to see is that this table says that it's not in the browser and it is not available in Traceur. So there's some gap there, and what you really do see is that there's they say less than what they can actually do, for the most part. And if you want, I'm going to share this talk, but this is Dave Herman's talk about comprehensions and how he wanted to, or what you really get by holding off on doing the generator and array comprehensions. And I have tons of stuff like this. I'm going to put it out on Twitter, and probably I'll add to a questions page on the slides if anyone's interested. But that's really all I got. Any other thing? All right. Thanks.